All right, we're going to finish off section 12.3 then today by turning attention to geometric series. So again, making the switch from sequence to series. When I give you the terms 2, 6, 18, 54, 192 with commas in between, those represent the terms of a sequence. But when I replace the commas with plus signs and we add those terms together, now we're going to be looking at what's called a series. All right? So to figure out how to find a geometric series, we have a formula. And the formula starts off the same as the one we had for arithmetic. It starts off with S sub n. Again, the S stands for sum, so we're adding things together. N represents, again, the number of terms that we're adding up. And you can see now the rest of the formula. The right-hand side is where all the work happens. We're going to have a sub 1, so this would be the first term multiplied by 1 minus r. Of course, r is the common ratio, and I'm putting that off to the side because you see the r in two different places there. But it's 1 minus r raised to the n power, all divided by 1 minus r. And the most common mistake is to not notice the power. Please notice that the power on the r is the same as the term number. So this power on r is the same as in fact, let me word that a little bit different. Same as the number of terms. Okay, it's real easy to make that n minus 1, but it's actually just n. Okay? And so not a very easy formula, so make sure you get that into your notebook. Pause the video if you need to make sure you can write that down correctly. And then we're just going to finish off this section by looking at some examples. So if I were to give you the geometric series 2, 6, 18, 54, and just remind you that it's geometric because if we take any one of these terms and divide by the one that comes before it, we always get the same thing. Therefore, the common ratio is 3. And if I asked you to add up the first 10 terms in that series, the formula says take the very first term, 2, multiply by 1 minus r is 3, raised to the 10th power. Okay, let me use maybe a broken line here. The number of terms we're adding up and the power in this formula are equal. Then we have to divide by 1 minus r. All right, so we put in a1, that's the number 2, that's our first term, multiplied by 1 minus r, our common ratio is 3, raised to the 10th power, and then divide by 1 minus 3. And now what you guys have to do is the order of operations in the correct order. You got to use your PEMDAS correctly. Inside the parentheses, we have subtraction and we have an exponent. Of course, when we have the choice, we do the, we do the exponent first. So 3 raised to the 10th power is 59,049. And I suppose we could subtract in the denominator since there isn't anything else going on there. And then 1 minus 59,049 is going to be negative 59,048. And then when we multiply by 2 and divide by negative 2, what we'll get as a result then is positive 59,048. And that would then be the sum of the first 10 terms of that geometric series. Okay? So you can tell that the calculations here are going to be a little bit tougher than they were with arithmetic. But if you take your time, you should be okay. Just take your time, use your calculator. Here's another example. This is a geometric series. You'd notice that if we take any one of the terms and divide by the one that comes before it, we get the same number, 2. Therefore, our common ratio is 2. And if I were to ask you to add up the first 12 terms of this series, what we have to do is take the first term, negative 4, multiply by 1 minus the common ratio, raised to the 12th power. So it's going to be 1 minus 2 raised to the 12th power, divided by 1 minus the common ratio. So here's our A1, here's our R raised to the nth power, with 1 minus there attached. And then downstairs we have our 1 minus R. Okay, again, parentheses first. Inside the parentheses, do the exponent. So 2 raised to the 12th power is 4,096. May as well subtract down in the denominator there. 1 minus 2 is negative 1. Then subtract inside the parentheses. 1 minus 4,096 is negative 4,095. And I ran out of room there, sorry about that. So we then have to multiply negative 4 times negative 4,095 and divide by negative 1. And what we'll get as a result then is negative 16,380. So that would be the sum of the first 12 terms. Now, before I go on to the third and fourth examples, I just want to point out, on these first two examples, on this one here, I asked you to find the sum of the first 12 terms. Please notice I did not need to know what the 12th term was. I did not need to know what the 12th term was. I only need to know what the first term is and the common ratio. Those are the only two things I need to know. Okay, so just observe that. Now the last two examples, the geometric series are going to be written out in summation form or sigma form. And again, I've got a really important thing that I've got to mention to everybody. How do I know that given this equation, 5 times 2 to the I, how do I know that it's going to be geometric? How do I know that's going to be a geometric series when I have 5 times 2 to the I? And here's the important part. It's going to be geometric if the equation is exponential. So remember from a couple months ago, exponential means we have a variable in the exponent. All right, and up here you can see that we have a variable I in the exponent, therefore it's exponential. And therefore I could ask you guys to find the sum of the first 8 terms. And what we're going to do is take the first term multiplied by 1 minus r raised to the n divided by 1 minus r. So we need 3 numbers. We need a1 and we need r. Okay? Do we have either of those right off the bat? No. Well, we can get the very first term by actually replacing I with 1. So the first term is actually going to be 5 times 2 to the first. We don't care about the second term or the third term or the fourth term or the fifth term or sixth, seventh, or eighth term. We only need the first term. And what's 5 times 2 to the first? 10. So our first term is going to be 10. And then the other thing that I need to mention that you can put right underneath this note is that the common ratio is always going to be the number base on the exponential. So what number has the variable attached to it, the 5 or the 2? The 2. Therefore, that's the r value. Excuse me. So that means in our formula then, I can replace r with 2 in both the numerator and in the denominator. And so the calculation I need you to then make with your calculator is, what's 2 to the 8th power? 256. Downstairs, 1 minus 2 is negative 1. 1 minus 256 is negative 255. And when you multiply 10 times negative 255 and divide by negative 1, what we get is positive 2,550. So the sum of the first 8 terms would be positive 2,550. Okay, and then to finish up, let's do one more written out in sigma notation. Again, we know it's going to be geometric if we have an exponential. Do we have an exponential? Do we have a variable in the exponent? Yes. And also, the common ratio is going to be the number that's raised to the variable power. So in this case, that's the 3 halves. All right? And so to find the sum of the first 6 terms, we need the first term. Well, to find the first term, we actually need to replace I with 1. So that's going to be 4 times 3 halves raised to the 1 minus 1 power. Again, we don't care about the second, third, fourth, fifth, or sixth term. We only need the first term. And when you guys do that math, what's 1 minus 1? 0. What's 3/2 raised to the 0 power? Anything raised to the 0 power is 1. And 4 times 1 is 4. So the first term is going to be 4. Then it's going to be 1 minus the common ratio, 3/2, raised to the 6th power, divided by 1 minus the common ratio. And again, just some computation on your calculator. I forget what 3 to the 6th is, okay? 729. 2 to the 6th power is 64, isn't it? Yep, so that's a 64. And downstairs, 1 minus 3/2 is negative 1/2. Inside the parentheses, 1 minus 729 64ths is negative 665 64ths. And then when I multiply that by 4 and divide by negative 1/2, let's see where we turn out. So I need to multiply that by 4 and divide by negative 1/2. And let me see if I punched out okay. I ended up at 665 eighths. 665 eighths would be the sum of the first 6 terms. Now, just kind of a curiosity, if anybody's calculator doesn't go to fractions very well, and you're looking for the decimal, this would also be equal to 83.125. Okay, so that's it for the geometric series. Hopefully with a little bit of practice, I know the equation, the formula is a little bit tougher to work with, but with a little bit of practice, I hope that gets a little bit better and a little bit easier. So now that you're done with this video, now you should be able to try all of the problems in section 3. Let me know, as always, if you have any questions or worries. I'll try to help you out. Otherwise, we'll talk to you soon. Hope you're having a good time.